Okay, now we're going to look at how we describe and identify all these characteristics on the graph of a function. So let's look at the first problem we got here. So here we have this function that's broken up, into two parts. So the minimum of this graph, the minimum, that's basically the lowest y value, the smallest y value on the entire graph, only the y value. So the lowest y value will be -3, because this is where it gets, to its minimum. And you don't have to label those points as 4, -3 or 6, -3. You just simply have to put -3. Now the maximum, you list the largest y value on the entire graph, and only the y value. So it occurs on this interval, but again, we only need to put 3. We only need to write the y value, 3. The graph is increasing on the interval. So when it just says interval, we're talking about the x values on, we're talking about like the domain that's increasing on. So x values, when you look at the graph, it's increasing on this, region here. But x values, if we go from left to right, it starts increasing when x is 6 and increases up to x is 8. So we put this as an interval notation, 6, 8. You could also put, x, in an interval notation, 6, 8 like that. Either one is fine, but eventually you get to the point where you're going to have to understand like that we're talking about only the x values. And use parentheses. I mean, there's actually some debate if you use parentheses or brackets. They're both, technically accepted, but I like to use parentheses because I think it lets it be more it lets it be less confusing when you're talking about like other parts of the graph, like domain, endpoints, dealing with intercepts. So I recommend using parentheses. The same thing with decreasing. We list the x interval, the values of x when it starts to decrease. So it would be it's decreasing on this on this portion here, and decreasing here. So the x values, here starting would be -2 up to 0. You see, then we skip this part right here. So we're going to put a union, and we start up again when x is 2 up to x is 4. We put 2, 4 again, like that. And then that would be our interval. The domain, remember the set of x values. So all of the x values on the graph. So we start all the way from the far left at -5. We include -5, so we put a bracket, comma, up to 0. We put a bracket there because we include 0. But we skip this portion here. So we're going to put a union, and then we start up again at 2 when x is 2. All the way up to x is 8. So 2, 8 in brackets. Again, the domain are the x values on the graph. The range are the y values, all the y values that the graph contains. So from the very bottom, we go from -3, the lowest y value, up to the largest y value, 3. From -3 to 3, bottom to top. So let me circle those. And since we don't skip any y values between, even though we have a gap in terms of x. We don't have a gap in terms of paper. We don't have a gap in terms of y. So all the y values are included. So then we can put -3 in brackets, 3 in brackets. That'll be the range. Right, the interval where f of x is greater than 0. when we say when f of x is greater than 0, we're talking about when is y greater than 0. And again, it says interval. We're talking about what x values. We list the x values that are included when x is more than 0. So x is more than 0 on this portion. It's more than 0 all along here, up to here. At 0, 0, it becomes 0. So we're actually going to go -5 in brackets, comma, 0. But we're going to put the 0 in parentheses because it's equal to 0 at 0, but it's saying greater than 0. So we're not going to include the 0. So we're going to put parentheses around the 0 there. And then the intervals where f of x is less than 0. So it'll be less than 0 along this, second part of the graph. Except we don't include this point because at that point it's 0, and we don't include this point. So we're going to put 2 in parentheses and 8 in parentheses because we don't include those 2. So it's less than 0 on the interval 2 to 8. Open circles or parentheses around 2 and 8. And again, for f of x is less than 0, we're saying when is y less than 0. So below the x-axis. And the x-intercept, there could be more than one, but there's actually 3 of them. There's the x-intercept here, here, and here. There's x-intercept at 0, 2, and 8. And when we say x-intercept, we're talking about the x values. So we just have to say 0, 2, and 8. It's understood that these 3 numbers represent the x coordinates at the x-intercepts. X-intercepts, remember when it crosses the x-axis. And the y-intercept, when the graph crosses the y-axis, there's only one point here. And again, we write the y-coordinates, which is at the origin, so 0, 0. We just have to put 0. Y-intercept is 0. Okay, let's look at another one now. And I recommend, trying, the problem first on your own. Maybe pause the video and then unpause it once you're ready to check your answers. That way you can, really see where you need some extra help on and what parts you're good at. But here we go. So for this graph, the minimum of the graph. Again, the y-coordinates of the lowest value on the graph. The lowest point here is at 3, 1, and we care only about the y value, so the minimum is 1. The maximum, the largest y value on the entire graph, that would be here, and the y value would be 11. The graph is increasing on the interval. It's increasing from here all along this up to here. And we care again about the x values. So it's increasing when x is 3 up to 10. We just put that as an interval, 3, 10. Parentheses around those. Decreasing. It's decreasing here and here. This first portion, the interval on this first portion, is from 0 to 3. So from 0 to 3. Again, we're talking about the x coordinates, 0 to 3. Then we skip this whole red region. So we're going to put a union. Then we start up again at 10. And from 10 to 13. parentheses around 10, comma 13. Right, the domain. The domain would be all the x values in the entire graph. They're going from the left to the right. There's no gaps or any jumps, so we can straight go from 0 to 13, all the x values. So put them in brackets because we include 0 and we include 13, so 0, comma 13. What's going on with this rectangle? The range are all the y values. So at the very bottom, the lowest y value here is 1. But the largest y value here is 11. Bottom to top. And again, we're not skipping any, there's no gaps or anything. So we can write it as 1, comma 11 in brackets. Now the interval where f of x is greater than 0. So it's greater than 0 on this entire graph, on its entire domain. So we can just go ahead and rewrite the domain again, 0 to 13, because it's always above the x-axis. 0, comma 13. And there, again, f of x greater than 0, that's saying when is y greater than 0, or when is the graph above the x-axis. Right, for h, when is f of x less than 0, or when is y less than 0? It's never less than 0, it's never below the x-axis. So you can just write never or nowhere. And for I, the x-intercepts, when does it intersect the x-axis? It never intersects the x-axis. So we have to cross this line some point. So we can write none or nowhere. No x-intercepts. There are none. There is a y-intercept though. The y-intercept is over here at 0, comma 10. But again, we just write the y coordinate at this point. We just have to write the 10. All right. All right, let's step it up. Let's look at this next one. Here we got a graph that's broken up into several pieces. So again, I advise you maybe to try this first on your own. So pause the video, try to see if you can figure all this stuff out. And then when you're good, unpause it and then check your answer. But here I go. The minimum of the graph, the lowest y value again, the very bottom would be -4, lowest y value. The maximum, now we would say it's 7. It would be at this point 3, 7, and we would say 7. But this is an open circle. So this point is actually not on the graph. So it's not included. So there actually is no maximum. So there's not going to be a maximum when you have an open circle at the highest point. Because that point is technically not on the graph. And since there's no way to say the number that comes before 7, we say none. Or it's undefined, we can say. The graph is increasing on the interval. It's increasing on this region here, in this portion. So remember the interval, we're talking about the x values. The x values here are from 0 to 3. We just put 0, comma 3 in parentheses. And again, this is why I like using parentheses, because if you have open circles there, then it doesn't matter. You don't have to worry about it because you're not including 0, 3 anyways. But if you had brackets, then you would have to adjust the parentheses. So it's increasing on this interval 0, 3. decreasing on these two portions. So in this first interval, the x values start at -10 and end at 0. So parentheses, -10, comma 0. Then we skip this red region and we start up again at 3 and we go to 10. So union 3 comma 10 parentheses. The domain, all the x values on the graph from -10 up to 10. Now here's the thing, you're like, well, aren't you skipping? You have a broken up graph. We have what's called a piecewise graph, but you're not actually skipping any x values between -10 and 10 because you're including 0, you're including the points after 0, you're including 3. It's just broken up. So you can just write your domain as -10 in brackets, comma +10 in brackets. Now, what you also could do, in case you're wondering, you can break the domain up into 3 parts. So I can first do this part. I can do -10, comma 0 in brackets, union, then 0 to 3 in parentheses, union, and then from 3 to 10 in brackets. And see, it ends up being the same thing because you're not including the 0 here, but you're including the 0 here. You're not including the 3 here, but you're including the 3 here. So you're including all the numbers from -10 to 10 in this notation or this notation. So both are actually right. Similar idea for the range. The lowest y value to the largest y value. So the very bottom, here we have -4. And we go all the way up to 7. The -4 would be in brackets. But 7, it's a parentheses because we don't include 7. We don't include this point. And again, even though it's broken up, we're still including all the y values between -4 and 7. We're actually not skipping any. And likewise, you could also break it up in the portions if you wanted to, but you don't have to. Right, the intervals where f of x is more than 0. So when is y more than 0? So it's more than 0, not here, but it's more than 0 on this red portion. So we can say 0 to 3, but also it's more than 0 up to 10. So again, we could actually go 0 to 3 in parentheses, union, and we can go 3, comma 10, but put the 10 in parentheses because at 10, it's equal to 0. It's not more than 0, it's equal to 0, 10. So you can write it like this, or you can just write 0, comma 10, where they're both in parentheses. Either way is fine. Now, when is f of x or when is y less than 0? So it's less than 0, mostly on here, but don't include the -10. Because at -10, it is equal to 0. It's not less than 0. So we would put -10 in parentheses, comma, 0 in brackets. Because we're not including -10, but we're going to include 0. Now the x-intercepts, we have two x-intercepts, -10, +10. Only the x values, so -10, +10. And the y-intercept, it would only be in this point here, and the y coordinate is -4. Now, not this one, because see, it's an open circle. It's actually not, included on the graph. So this is not going to be the y-intercept. The y-intercept would just be this point here, -4. Okay, one more now. One more of these guys. So I hope we're catching on to this. The last one to try, and we actually fix this. It should be greater than a less than sign. So once again, try this on your own first, I advise. Then check your answers once you give each section a shot. But here we go. For this graph, the minimum of the graph is going to be at this point here. The y value, the lowest y value is 2. We just write 2. Maximum of the graph, the largest y value would be over here, 14.5. The graph is increasing on the interval. It starts increasing here, all the way up to there, all along this interval. So from 14 up to 31 in parentheses. Where is it decreasing? Well, it's decreasing before that. It's decreasing on this region here. So from 0 to 14. Then we skip this red region. And we start up again at 31. And we go until the very end here, which will be 34. It will be 34, 14. Where the domain of the graph is. So all the x values on the graph are from 0 to 34. We include both of those. Since we have closed circles, so we put them in brackets. 0, 34, all in brackets. The range of the graph is the smallest y value to the largest y value. So all the y values would go from 2 up to 14.5. This is the bottom. Top would be up here. So we include those in brackets. So 2, 14.5. Right, the intervals where f of x is greater than 0. So it's greater than 0, or when is it above the x-axis? It's on the entire domain. It's always above 0. So we can just write the domain again, 0 to 34. And remember, f of x, we're saying, when is y greater than 0? And then for h, the intervals where f of x is less than 0, it's never below the x-axis. So y is never less than 0. You can say nowhere, never. And the x-intercepts, where does it intersect the x? Where does it intersect the x-axis? Never intersects the x-axis. None. And the y-intercept, where does it intersect the y-axis? At just this point here at 0, 13, but we just write the y coordinates. We just write 13. All right. Okay, so now just a couple more of these to, master your skills, but feel free to take a break if if you feel a little there's a lot of math we've been doing. take a little break, and then we're going to finish off with these graphs and these identification kind of fill in the blank problems. Okay, so looking at this graph, problem 10, we have the graph of f of x, and then graph of g of x. Let's make g of x red. So where does f of x equal g of x? So in other words, this is just asking for where do they intersect? When are they the same value? And they're going to be the same value at the point 2 comma 5, because that's where they intersect. At the point 2 comma 5. All right, what is f of 4 plus g of 4? F of 4, remember, look when x is 4, what's f of 4? F of 4, we talk about this point here, 4 comma 7. So then f of 4 is 7. We have 7 plus what's g of 4. This is kind of hard. It doesn't give you like a clear. It's like right before 6. So you could say 6, but you know, it's like that point there, they did a very good job of making it clear what it goes through, but I was going to say that it's going to be like 5.8. As long as you get the idea, that's all that matters. So we'll just go with 5.8. So then f of 4 plus g of 4 is the same as 7 plus 5.8, which will then be 12.8. What is g of negative 2 minus f of negative 2? G of negative 2, we look when x is negative 2. And if you look at this point here, and then this point here. So f of negative 2, this point, that's like a negative 2, 1, it looks like. And then again, this is like kind of sketchy, doesn't give you a clear coordinate on that. But I'm going to go with negative 2, comma, like 3.2. G of negative 2, we'll say it's for the squigglies. G of negative 2 is about 3.2. 3.2 minus f of negative 2, which is 1. And that'll be 2.2. And on what interval is g of x more than f of x? So when is the red line above the black line? So the g of x is greater than f of x all along this portion up to here. So assuming that this graph goes on forever to the left, we would say negative infinity up to this point or up to 2. Okay, and now these last two graphs are pretty simple, again, once you just know what the notation is. So here we have h of t equals to 2t minus 5. H of t equals 2t minus 5. H of t equals 2t minus 5. So h of negative 4 is asking for the value when you plug negative 4 in for t. So this would be 2 times negative 4 minus 5, which will be negative 8 minus 5. which will then be negative 13. For B, we're told that h of t equals 23. So solve for t. In other words, you're just going to make 23 equal to 2t minus 5. Then we solve for t. We just add 5 and then divide by 2. So 28 equals 2t. And 14 will be equal to t. For C, h of 13. All we do is plug 13 into here. So h of 13 equals 2 times 13 minus 5, which is just 26 minus 5, which is just 21. Oh. And the last one for h of t, we have h of t equals 33. What's t then? So then what we do is just set the equation again equal to 2t minus 5. So negative 33 equals 2t minus 5. And then solve this for t. So add 5, get a negative 28 equals 2t. Dividing both those by 2, we'll get t is negative 14. Our final two. Oh, these are just quick identifying. So we're going to look at this graph for g of x. So when we're looking at g of 2, what is g of 2 equal to? Well, that's just saying, what's the y value when the x value is 2 on this graph? So the y value when x is 2 is just referring to this point, is just going to be 9. We're just talking about the point 2 comma 9. Now, in B, we have that g of x is equal to 3. What's the x value? So we're told the y value. We're told the y value is 3. So we want to find what's the x value when the y value is 3. We're kind of working backwards now. And we're just looking at this point here. When the y value is 3, the x value is 1. And then for g of 0, when x is 0, what is y? So we're talking about this point here. When x is 0, y is 1. G of 0 is equal to 1. And for the r of x graph, looking at this line, r of negative 1. What's the y value when the x value is negative 1? Negative 1 going on the graph. We're looking at this point over here, which is going to be at negative 1. Looks like negative 110. So when x is negative 1, y is 10. So r of negative 1 is 10. And b, r of x equals 4. So when y is equal to 4, what's the x value? So when y equals 4, talking about this point here, talking about the point 1 comma 4. And the x value here is just 1. Take that one. The last one, r of 2. What's the y value when x is 2? So when x is 2, we're talking about this point 2 comma 1. So r of 2 is just equal to 1. All right, and that's it for this practice test. So I hope this helps a lot with functions. So again, let me know any questions or any points or any parts that maybe were confusing. Um, don't worry, you're not gonna hurt my feelings. I'm a teacher, but just I would kind of like to know if like maybe I went over something too fast, or maybe I just spent too much time on something that was really simple. But let me know in the comments, and if you want me to maybe go over something again. So hope that helps. Good luck, and subscribe if you haven't already.